Okay, our last section of this chapter on radical and rational functions, we're going to be solving more of their equations and inequalities, which we did in the middle of the chapter, but we really haven't been working with them lately. So let's get started. In order to solve radical equations, if possible, you need to isolate the radicals. Now, we had some earlier on where we couldn't, and it was easier to do like a substitution. I think we're going to see some of that again today, but we're going to start with somewhere you definitely can isolate the radicals, do your algebra steps, and solve your equations. You always want to then raise to the appropriate power if it's third, fourth, fifth, whatever it is, since we have different roots that we'll be dealing with. Repeat until you have no radicals remaining. And then last but not least, make sure you're definitely checking your solutions and discarding any extraneous solutions, because you definitely will have extra values that look good, but really when checked in the original equation, do not make it true. So let's see what some of these are going to look like. All right, let's start with this. If I have 12 equals 4 times the square root of 2x plus 1, I'm looking like I could solve this right away, but remember, we want to try to isolate the radical. And if we don't have that radical, in this case the square root by itself, we definitely need to do that. So step 1, divide by 4, simplify it. We'd get a 3 equals. Now we would have the square root by itself. With that square root of 2x plus 1, we could undo that square root by squaring it. So that means we have to square both sides. Equals, when we take a square of a square root, we only get what remains underneath. And then 3 squared, we should know, is 9. So we move the 1 over by subtracting, get 8. And we get 2x equals 8. Divide by 2, x equals 4. Now check it, putting it back into the original problem. 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3. 3 times 4 is 12. 12 equals 12. Looks like we should be good. And we get a solution of x equals 4, and we did. Okay, so pretty straightforward, radical, isolated, then the algebra steps took over. They all will not be as smooth as that. So let's look at this one. Now we have cube roots. We have basically a cube root on the left equals a cube root on the right. Now it said isolate the radical if possible. Because they're both cube roots and they are, so to speak, isolated by themselves, each on their own side, it would make sense to just go ahead and cube everything to start. So that will be our first step. So if we do a cube of our equation, and cubing a cube root is just like squaring a square root. You always get what's underneath that radical. And so we have 8x plus 11 has to equal the 9x plus 1. And again, variables one way, numbers the other. So let's bring the variables over to the left. So we'll subtract 8x from both sides. X or 1x, and we'll move the 1 to the other side by subtracting. We get an x equals 10. And now let's go ahead and put that in as a cube root, and let's check what we've got. So here's our check step. 10 times 9 is 90, 91. We've got the cube root of 91 on this side. On the other side, 8 times 10 is 80. 80 plus 11 is 91. We've got the cube root of 91. Okay, don't see any problems. Seems to check. And our value was x equals 10. Okay. Next one, we're back to a square root. Some of us would call it our comfort zone. But look carefully, that square root is not isolated, is not by itself. So job 1 would be to get it by itself. So even though that 3x is not underneath, it needs to move to the other side. We could get a little complication with that, but that's the process we have to follow for accuracy here. So let's move that 3x to this other side. We would still have a square root of 4x plus 2 on the left. That 3x moving the other side would be 1 plus 3x. Our radical now is by itself, so our next step was to undo that radical. So we have a square root, we will undo that with a square. Over here we have to square that binomial, which means we're going to have to do some FOILing. Not bad, we've done that before. So 4x plus 2 is all that remains on the left-hand side. On the right-hand side, if we put this in order, we would get 9x squared. Take the product of the two, 3x, doubled would be 6x. Square the last, which is a constant term in this case, we would get a 1. Now it looks like we'd have a quadratic if we moved it over, so let's do that. Let's make this left-hand side 0. Move the 4x over as a negative 4x, and we would get 2x. Move the 2 over as a negative 2, and that would leave us a negative 1. Probably the first look here would be to try to factor. Let's try the 3 and the 3 as our first choice, and the 1 and the 1. That doesn't look like it's going to do it, because we definitely needed 1. We need a plus and a minus. Yeah, that's not going to factor. Even if we used a 9, because we need a 2 in the middle. If we used a 9 and a 1, so from here, quadratic formula looks like our only option. So here we go. X equals opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. 2a is 18. All right, let's do the math underneath. We've got 4 times 9 is 36. 36 times 1 is 36. Got 2 negatives there, so it looks like we're going to have, if we come back up here, negative 2 plus or minus it's the square root of 40 all over 18. Now, square root of 40 definitely has a perfect square in it. Our 4 is hiding out, so think of the 40 as 4 times 10. We'd have negative 2 plus or minus 2 root 10 all over 18. We can do some reducing on this because we have whole numbers all out in front. So I believe if we're looking for solutions to this, and what I forgot about, are we looking for real solutions or not? We've got a negative 1. We definitely don't have imaginary, but negative 1 plus or minus square root of 10 all over 9. They say the answer is, and I bet you if we put that into our calculator, we would get those decimals. Now again, by checking what happens, probably that one value, that negative, you can see the approximate values of it. If you put that here, that would leave you with a negative square root. That would make it imaginary, complex, and so that's why we have eliminated it. Okay? So that would make this statement false. So you are going to get some messy answers. This would be the exact form probably of those with our quadratic done. So don't forget about possibly using a quadratic formula. All right, next one. We have solve, and we've got the square root. Again, it's isolated on the left. It's not on the right, but I think we're going to have to multiply from here. And in order to do that, we need to take the square root of both sides. So doing that, right away, square root of the left, square root of the square root is there. We're going to take the square, sorry. And let's go back to black here. So taking the square root of a square, we would get 3x plus 4. However, we're into FOILing over here, so ready? First times first would give us just x. Outsides, Or how about take the product of the two? That would be negative 2 times the square root of x, doubled, so negative 4 square root of x, and then square the last would be plus 4. So square root of a square gave me just an x. Now right away we're looking at, oh, we've got plenty of x's and y's, but if I need to get this square root by itself, we're going to move the x over by subtracting x and the 4 over by subtracting 4. See what happens now. We would get 2x plus 0 equals, the only thing remaining is that 4 root x. Now let's move that 4, because we don't have the radical isolated, and we're looking at 1/2 x, or some people might say x over 2. So how do you undo a square root? You square it. So we've got x equals, and here we would have x squared over 4. Gosh, to get the x's together, everything on one side, looks like we're going to have x squared over 4 minus x equals 0. We could factor out an x, and we'd have 1/4 x minus 1 equals 0. So we could say we have a value of x equals 0. And from here, we would get x equals 4. Oops. How do I make that into a 4? Like that. Because 1/4 x equals 1, we times it by 4, x equals 4. So we get a 0 and a 4. Now, the problem would be, let's go back into the original problem and do our check. If we put a 0 in, okay, let's use a space over here for our check. If we put a 0 in, we'd have 3 times 0 is 0. 0 plus 4 is 4. The square root of 4 is 2. Does that equal, square root of 0 is 0. 0 take away 2 is negative 2. Looks like that 0 is not going to work. All right, let's try the 4. 3 times 4 is 12. 12 plus 4 is 16. The square root of 16 is 4. And on the right-hand side of that, square root of 4 is 2. 2 minus 2 is 0. Ooh, that doesn't look like it works either. What do I have for a solution? Hopefully it says no solution. Yes, all right. So we did that correctly. It looks like we have 2 valid solutions, definitely called extraneous in this case, but neither one of them worked once we got the radicals isolated. All right, moving on. Now let's talk about an inequality. When we've done these in the past, we sort of look at them like proportions, but again, you must have the radical by itself. So if we have the radical by itself, which we do, then we should be able to square both sides, first step. That would give us just the x plus 7 is greater than or equal to 16. Solve for x. X is greater than or equal to 7 subtracted from 16 would give us 9. X has to be a value greater than or equal to 9. So let's just try the 9 and see if it makes it true. So our check step is if we put a 9 in, 9 plus 7 is 16. The square root of 16 is 4, is greater than or equal to 4. That is a true statement. So I believe our solution here should be the x is greater than or equal to 9. Okay? Lastly, if we have an inequality, like we had earlier in the chapter, and we're not going to isolate it, it makes sense to take each part and set it equal to y. So we're going to take this first part and let it equal y, and then we'll take the second part and let it equal y. So we're putting them both in there, and then basically we're doing a y equals situation. Okay? So if you graph the first one and then you graph the second one. Sorry, I did not make a visual for this. So under y sub 1, you could make the first inequality. And under y sub 2, you'd make the second one. And because if we go back and we read it left to right, we're looking for when is y sub 1 less than y sub 2. When is the first equation less than y sub 2? When does the first equation fall below the second equation? And that's what we're talking about when we say that's what we need to look for. So it's probably going to be a range of things. Use your asymptotes, use your vertex points, things like that to tell. And if we had a question on this, we can go back over it. But it looks like we have two specific locations. We have from the negative 8.5 and 1. So there is one situation. And you can trace to these points, or you can do min-maxes. And x is greater than 7.5 is the second one. So anything between negative 8.5 and 1 and anything greater than 7.4 positive. Okay. So with that, I think we should have enough tools to get you started on this section, isolating radicals of all types and using the grapher to help as well to see your solutions. Especially on that last one, if you have questions, bring those to class. We'll look at the graph because I forgot to put one up here.